Here we have to derive formula for energy stored in charged parallel plate capacitor. So let's consider two plates which are uncharged initially, and gradually we are providing charges on these plates. So we can say the potential difference between two plates is charge stored on capacitor upon its capacitance. Now let's try to find out small work done to get small charge dq, which is q into v. So if we substitute the value of v, which is q by c, we will get q by c dot dq. So we are ready to find out total work done to get the charge from 0 to q, and we are already find out your small work done. Now we know that integration of x raised to n dot dx is x raised to n plus 1 upon n plus 1 plus c. So let's use this information to integrate. But here your variable is q. So we can say 1 upon c is constant, take it outside. We just have to focus on integration of dq from 0 to q. The power of variable is 1. So its integration must be q raised to 1 plus 1, or we can say 2 by 2. And your limit is from 0 to q. So from upper limit we will get q square minus from lower limit we will get 0 square, or we can say the total work required to store the charge is q square by 2c. Now we can convert this formula in two different ways. If we substitute q is equal to cv, we will get c square v square by 2c, or we can say half cv square. This is the second form of our equation, and we also know that q is equal to cv. So we will get work done is equal to half qv, which is third form of our equation. So finally we can say this work done will be stored in terms of potential energy, will be q square by 2c, half cv square and half q into v. So ta-da! Now we get the potential energy. Now let's try to find out potential energy density, and for that we have to simplify our formula of potential energy using charge density. We know that your charge density is q by a, so we can make q subjective and we'll get sigma into a, and we also going to need your capacitance, which is nothing but epsilon 0 a by d. So if we substitute these two values, your potential energy will become, instead of q square we'll get sigma square a square, and in denominator capacitor is epsilon 0 a into d. So here 1 power of area will cancel out. We will get sigma square upon 2 times epsilon naught a into d, which is nothing but your volume. So here we get potential energy upon volume as sigma square upon 2 epsilon naught is your potential energy density. This equation represents potential energy stored in parallel plate capacitor. Ta-da!